Good afternoon to everybody. I think they deserve the prize because I will teach you how to increase the performance two times of the channel pjsip. So just doing some very simple things. My idea with this presentation was actually to test channel SIPP and channel pjsip. The problem is which channel to use. I'm in the middle of a project that I have to choose a version of Asterisk and the type of channel. And okay, where's the data regarding the performance of the channel? There's absolutely no data on the internet regarding the channel's performance. So I don't know if pjsip is better or worse than chan SIPP. And when I started to create this presentation, I didn't know the results either. So I submit the speak and say, I don't know the results. I just have to do it anyway. So I started to prepare the presentation. So my name is Flavio. I'm from Brazil. I'm CTO of SIPP in Brazil. SIPP started in 2010 with offices in São Paulo and Florianópolis. We developed soft switches, multi-tenant PBXs, and session border controllers. We have more or less 75 ITSPs running our software in Brazil. And we use Asterisk as a media server, mainly for the multi-tenant PBX. The current architecture of the PBX is we have a SIPP proxy, gateways, and a media server aside the proxy. So most of the calls do not traverse the media server. They go straight from OpenSIP to the gateways. This gives us a very large scalability. But there's a catch. There's a problem too. You have to deal with scenarios that are very hard to troubleshoot, like the call comes to the gateway and goes to the IVR, and then goes back to the phone, and the phone do a forward to another phone that transfers to another phone. And to troubleshoot scenarios like this becomes a nightmare because you have to troubleshoot many different calls, many different signalings from one phone to the other. So we are building a new version, and we are looking at an architecture where we traverse all the calls through Asterisk. We will lose a bit of scalability, but we'll have a single call. And we have a single point where we can do all the troubleshooting, that it's much easier. But I have a question. If this one Asterisk will be enough, or how many Asterisks we will need on this architecture? Which version of Asterisk should I use? Should I use Asterisk or something else? That were the questions I have before starting testing. So the objectives were, which step channel should we choose? Are there significant differences between Asterisk versions? Are there significant differences between the channels? How many CPSs to expect from Asterisk? How many simultaneous calls to expect? That's where we have a lot of questions before we start. There are some cautions too that, okay, I don't want to get in any war. So there are developers, and all developers love their children. So the developers of chan SIPP love chan SIPP, and developers of chan pjsip love pjsip, and I don't want to hurt anybody. So the idea is to adopt a scientific approach. Results are results. I didn't develop any of them, so I'm completely neutral related to this. And make the tools available for anyone willing to replicate the tests. So the tools are in the GitHub. You can download if you want to replicate the tests. I will give you the URL at the end of the speech. Methodology, the idea is to generate traffic until retransmissions start. So the cut is retransmissions. Decrease the traffic until stabilization. It takes some time to do the test. You have to, let's say, go to 500 calls per second, and it fails. Then you go to 250, and it's OK. Then you go in the middle again until you find the right performance. And to have a phone call with music on hold to monitor quality. So you need to have at least a good call during the testing to make sure that the PBX is working. Same hardware for all tests. And an Asterisk restart after each test. So each test we have to restart to make sure that we don't have anything in memory or caching or something that could. This lead to a lot of time testing. Failure criteria. I have a professor on fatigue at the time in university, and we used to do stress testing on still. And there was something that he always mentioned. We need to have a good failure criteria. A bridge does not fail when it collapses. A bridge fails if it deflects more than 5%. No one wants to cross a bridge that deflects more than 5%. So the idea was the same. Okay, so our failure criteria is maximum of 5 retransmissions, at least 5 minutes of sustained performance. This is something really, really interesting. You start a test, and the test is okay. You are in the 240 seconds, and it's okay. 280, and it starts to retransmit. And once it starts to retransmit, the test is all queued. It starts to retransmit forever. It don't stabilize. So we need at least 5 minutes to make sure that the test is okay. So it takes some time to test. CPU below 60%. If the CPU is above 60%, this test is a failure, in my opinion. Clear audio while on the test, so it doesn't. If you have a test and your audio is bad, the test failed anyway. So this is a failure criteria too, and at least 5 minutes. So then we started with very simple tests, like call to an echo channel, no media. The good thing about testing the call without media is you really measure the channel. If you use media is usually a bottleneck. So you're going to hit the performance of the media before the performance of the channel. So a test without media, it's actually one of the best ones. Then a call to an echo channel with media, just to make sure that we have enough simultaneous calls. And the last one was the register with a qualify, so register with options on the other side. So we have to script a bit using the tool SIPP, SIPP Performance 2. I wanted to test Asterisk using stock Asterisk, like apt-get Asterisk, absolutely no improvement, no tuning. But there's one tuning that you can avoid, is the maximum number of files. If you don't set max files equals something bigger than the 1,000 that it's the default, you will have to test so bad, like not even 30 calls per second. Right? So the first thing you have to do is you have to increase the max files, the default. If you don't increase the max files, it's funny, there are many PBXs installed and still with the max files in 1,000. And when we start to have retransmissions, lost packets, and say, hey, this asterisk doesn't scale. No, not exactly. If you let max files with 1,000, that is the default, it really does not scale. And I unloaded all the unnecessary channels, IX, motif. It's simply removed all of them just to make sure that they wouldn't have impact. I chose a small server, a very inexpensive one. There is a quad-core Celeron with 2 gigahertz, 4 gigs of RAM, 16 gigs of SSD. It's a small machine because this is a target for something that we are doing as a distributed asterisk and something like a blade. It's really very inexpensive, costs less than $200. And it runs asterisk very fast. Okay, tests with no media or authentication. So we are using SIPP. The dial plan is very, very simple, right? It's just an echo test, and we have another extension just for the audio quality that it's music on hold. So it's a quite simple test. If you want to do it, you can do it your own server very easily, very easily. It's just a matter of installing SIPP. I have used the version 3.5.1 to make this test. So let's see. The first test is echo test without media. So for asterisk 11, we have 295 calls per second. For asterisk 13, 295 calls per second, and for asterisk 15, 295 calls per second. That means that we are not doing anything with ChanSIP lately. we are having more or less the same performance of ChanSIP since the version 11. And the version 11, you don't have pjsip because pjsip was introduced on the version 12. And I tested only with the LTS versions. Why? Because I don't want to put in a project any version that was not LTS. It's not long-term support, because if you're going to build a product, we hope that they have a long run. And then migrations are always a pain, so let's try to find something that it's long-term. Then we tested with pjsip, and we got 510 calls per second with pjsip and Asterisk 13, and 500 on Asterisk 15. So pjsip is actually faster than SIPP as a SIPP stack. But there's a catch. It consumes a little more CPU than SIPP. Right, so it uses the server, how can I say? It's more efficient on using the resources. It uses more resources than SIPP and gives you more calls per second than the SIPP. This is, in my opinion, one of the most significant tests, because it really measures the SIPP stack. You're going to see the audio test, the echo with audio. The results are very similar. At the end we'll do the questions.
What is the call duration of this?
The call duration is 90 seconds. On this case, there's no call duration. It's 1 second. There's no media. And the winner is pjsip with 1317.2, 510 CPS. But we went to almost 60% of CPU, right? So the CPU was very, very high on and we have 4 retransmissions. We were on the edge of the system in this case. But these are interesting results. Echo test with media. The next test was to do exactly the same test, but now with media, with a pickup file. So we send the G711 to the server. 1.5 minutes of call duration is more or less the average for business systems. If you are a telco, probably if you're doing termination for call centers, probably you're going to have 30 seconds, 20 seconds. In ACD, an average call duration that it's lots smaller. You can test with a smaller ACD if you want, right? It's just change the last parameter, the -d, and you're going to change the duration of the call. And we have different results here. It's, when you look at the picture, you see, hey, Asterisk 11, it's much better than pjsip, but actually the graph, it's kind of misleading. It's 37 for Asterisk 11 and 35 for SIPP, right? And for Asterisk 13 on pjsip, we have 32, and Asterisk 15, also 32 calls per second. What's the explanation? What's the reason for now pjsip to have a performance that is worse than SIPP? CPU. It uses more CPU, so it can actually decrease a bit the number of simultaneous calls. You have less CPU to process more media channels. Quite interesting, the results. The results are actually the opposite from when you don't use media. Actually, SIPP is very, very fast in terms of how it processes the signaling, but it consumes more CPU. So it gives less CPU to process calls. When you go to simultaneous calls, simultaneous calls. It gives a little more simultaneous calls for Asterisk 11 compared to Asterisk 13 and 15, right? So this is what we got in terms of echo channels with media and in both directions. 3,338 simultaneous calls in a box that costs less than $200. So Asterisk really scales to, if you put it more hardware, you probably have even better results. And the winner for the second test is Asterisk 11. It supports more simultaneous calls than the newer versions, right? Using media is not a good test for the SIPP stack because the media is the bottleneck, not the stack. The difference is slow, so the tests are not totally conclusive. I think if you do this test 3-4 times, you usually have 34 in one, 34, 35. It's almost a tie. It's more or less the same performance for one channel or the other. I think it's not statistically significant between one version or the other. So the winner here is this SIPP at the 1125.3, 37 CPSs. And the last test is registrations per second. And in registrations, we did something interesting there. We used the registrations and we used this out-of-call message because we have options. So we had 2 XML files, one to handle the registrations and another one to handle the options. Options are used to qualify the client on SIPP. You ping the client just to know the round trip time to that specific client if it's up or not, right? So if I want to build a PBX, I want to ping my clients. If I want to build a distributed PBX, I want to ping. So I did the test with the options. And this gave me a lot of work because actually the first version that I tried with Asterisk 13 was the Asterisk 13.13 certified, not the latest version. And I should have known that 13.13 wouldn't work. Twice in the same version. Nah. Huh?
In Brazil, it didn't work at all.
It didn't work at all.
Yeah.
But actually, 13.13 is broken, and it doesn't qualify. It doesn't send the options. So I have to update to the latest version, and the latest version is working just fine. And it's funny because I had to retake all the tests back with the version 13, with the latest version. And we got different results with the version 13 certified and with the latest version and on the previous tests. So the previous tests were created using the latest Asterisk. And it's funny because the first test, I went back to one of the first tests and I got a very poor result with the latest version. And say, how come? I was using Asterisk 13 certified, now I have the latest version, and I have less than half of the calls per second. And then we start to investigate some interesting things that I'll show you. Okay, so let me show the results. Another thing, instead of using a single user, I have registered 4,000 users. So I created a conf file with 4,000 users, and then I migrated this SIPP.conf to pjsip.conf with 4,000 users. And with some VI black magic, we got to make everything working. The files, the confs are also on the GitHub. You can download too if you want to test, right? And then the results. At this time, they are very significant. We have 850 registrations per second on Asterisk 11, and less than 170 on Asterisk 13 and 15. And this called me attention. There's something wrong with the newest versions in terms of registrations per second. And this is something that really needs some attention because if you think of 160 registrations per second, it's a lot. If you think a registration lasts for 120 seconds, it should be enough for more than 10,000 users, right? But if you turn off your server and turn on again, what's going to happen? They all register at once. And if they all register at once with this performance, you're going to have a large problem.
With your ISP.
Huh?
A problem with your ISP would bring you to your knees.
Yeah, it's true. So this is something that we have really to think about. And I tried to find the problem. Actually, my first theory was it was SQLite, but actually Asterisk 11 also runs on SQLite for registrations. So it's not SQLite. It's something related to the CPU, because for Asterisk 11 we have 35 IOPS for 200 registrations per second, and for 13 the same 35 IOPS. But the CPU goes from 7.5% to 25.6% on the newest versions. So this is something that you really have to pay attention, right? And the winner in this case is the 11.25.3 with channel SIPP. It's still, if you want to run a large PBX with lots of registrations, is still the one that has the best performance. Things we've learned while searching something else. The problem I had with the Asterisk certified 1313 was actually something really interesting. I was getting, just after upgrading to the latest version, I was getting very, very poor results. And I was trying to find why I'm getting poor results with the latest version of Asterisk 13. And then I say, maybe a CDR. And then I went to the server and say, let me see which CDR modules I have on the system. And I look at the modules, and there was no CDR. Not even the CSV. I say, well, kind of strange. No CDRs in CSV format on Asterisk 13. And then I went to a file, this file, SQLite, SQLite.db. This file had something like, after the test, something like 1 gig. You say, what the hell, there's a file with 1 gig in the system? And then I downloaded the client for SQLite, did a SQLite on the file, and there was a CDR there. I say, how can I have a CDR without having a CDR module? And then Googling a bit, I discovered that we have Asterisk real-time. Asterisk real-time should be only about configuration, right? But Asterisk real-time for SQLite 2 really have, it points to a file, the SQLite DB, the SQLite 2, and it generates a CDR. So all Asterisk 13, all Asterisks since Asterisk 11 are generating CDRs for nothing. If you do make samples, they will insert this configuration file there. Once you remove the SQLite 2, you remove the module, put a no-load resconfig SQLite, the performance of the performance of the channel doubles. That's what I said at the beginning of the presentation. If you simply remove the module, your SIP performance will double, right? Because you're not saving CDR to a SQL database with a journaling system in some cases. Just remove it. It's something, probably someone missed this thing, or I'm missing something maybe. But it's funny to see the CDRs on SQLite. And the funny thing, why in Asterisk 13 it didn't happen in the 1313? Because in the Asterisk certified, they don't load a lot of modules. And one of the modules that they don't load is the SQLite. And actually, it's not a CDR module. It's a Asterisk real-time module. It's a configuration module. I don't know why it generates CDRs. So removing these CDRs increased the performance of the first test from 270 to the 510 calls per second. Takeaways, lessons learned. If you don't change the max files, you won't get not even 30 calls per second, right? In my opinion, the new pjsip is faster than the channel SIPP. The problem is the Asterisk 13 is slower than the Asterisk 11. It's not the channel. What I'm saying, the things that we are experiencing are not related to the channel itself. They are related to something between the version 11 and version 13. in terms of performance registrations only. Look, the performance for calls is quite good. The performance of registrations is something that we need to care about, right? Asterisk 1313, certified 6 is broken when using qualify. It simply does not send the options and it don't work. Remove resconfig SQLite modules to double the CPS. Registrations performance decrease in newer versions. I will open a ticket after the conference to discover what it is. I really don't know what it is. I tried to figure out on the last few days and couldn't. It's good enough for media servers, for gateways, and even for mid-range PBXs, right? But for a large PBXs, I would recommend to have a middle register proxy in front of the server to handle registrations and to handle all the SIP signaling in front of the box. If you're running small to mid-range PBX, it won't have any issue. And for the media server, actually, it's quite nice. Conclusions. We will choose the Asterisk 15 and pjsip for multi-tenant. We are not dealing with registrations, and I want to have the latest resources. So it's an LTS version. SIPP is not supported anymore by Digital. It's supported by community, but not by Digital anymore. Probably will be deprecated in future versions. The performance for simultaneous calls and CPSs are okay. So for our application, it's quite okay. Load balancing in the middle register will be mandatory in this case for the multi-tenant PBX. For the distributed PBX, there's another project. We will choose the Asterisk 11 because the registration performance is still a little better. Okay. Please reproduce it. The code is available on GitHub, Flavio, Astricon 2017. You can download and test your own servers. Well, questions.
Right,
okay,
questions?
go ahead.
Running now.
Just have a question with regards to your comment of max files and calls per second. I can understand of the file descriptor limit with simultaneous calls because you use 2 ports per call, but why would it also have an impact on just calls per second of 0 length duration?
It impacts the number of file descriptors that you have on the system. And with file descriptors, if you don't change, it will, I don't know, the test won't go through.
What is it using the file descriptors for?
I think for each SIP channel, it creates a new file descriptor.
Yeah, so it's for simultaneous calls you need it, not for the calls per second then.
Maybe. No, but even with the 1 second, we have limitations on calls per second if you don't increase the max files.
Hello.
Okay.
Firstly, thank you. This is great. I'd love to see these tests put into the test suite so that on every release, we know that Asterisk hasn't regressed. So that'd be, I don't know why we haven't done it before. And then have those results publicly available. It just makes sense. Anyway, nothing against your talk, but 15 isn't an LTS. I just wanted to make that really known so that no one goes away and thinks 15 is an LTS.
15 is not an LTS?
No.
No, 15 right now is in beta, is in release.
So it got released.
Candidate 1.
So it got released yesterday, but it's not going to be an LTS.
Oh, sorry.
That's
Thank
okay.
you.
I just wanted to make sure everyone was aware.
Okay. I thought that the odd versions were LTS.
Any more? Yes.
Hi. I did the same kind of testing in our environment, and we found good result when we use SOSRI for registration and for the call. So SOSRI module is very good, and for first time when we are registering or we are making the call, the load is high. But the second time, third time, when all the information is already loaded in SOSRI module, That is very fast. So, what do you think about using the SOSRI module?
What I'm using, I use SIPP, and we tested for 300 seconds. If they last for 300 seconds, it's okay or not. Sorry, maybe I didn't understand your question.
There is a module, SOSRI, the .conf in Asterisk. So it is loading everything in the module. So
Yeah, sure.
if you are using the real-time Asterisk real-time to create the endpoints, in that time
I was using the configuration file.
yeah. So only you need to enable it, and after enabling it, you can say that registration will expire in such and such second, and there are many configurations. So I found it useful. So I think you should test with SOSRI also.
But for the test, we didn't use Asterisk real time, or we used simply the configuration file and loaded the configuration file.
Oh.
And the modules, we used the modules that were in the default configuration. Right.
Anyone else? Oh, yes, one over there.
Great work on the testing, by the way.
Thank you.
You had mentioned that that you would view Asterisk as a good solution for a small to medium sized deployment, and I see your particular perspective on that as it relates to how many registrations it can deal with post boot up or network event or whatnot. Would you think that a session border controller of some type in front of Asterisk would increase its capability to a very large, making it much more scalable, or not
Yes.
so much?
Yes. If
You would, okay.
If you have a middle register, someone in the middle that handles the
just-
register, or it can improve the performance. But actually, we have to put things in perspective. That I would say that 95% of the PBX implementations have less than 120 simultaneous calls. And most of them will not have more than 10 calls per second. Yeah. So I think Asterisk is great for 99-something% of the whole market. And I think it's great. I really enjoyed this morning the talk about the Jim Dixon, because I remember in 2003 how telephony was. We were paying $10,000 for an E1 card. And the first Tormenta cards started with $1,500. It's really awesome. And when Asterisk came, we were paying a lot for license for IVR, license for recorder. I think the Asterisk is was the most disruptive software in the most successful open source project in the history. And if you see the numbers on Google and how many Asterisks have compared to any other thing, it's huge. Yeah? But it covers 95%. But there's 5% that if you really have, let's say, 10,000 users or 20,000 users, you need really to do something else. Maybe an SBC, it's the right solution, or a proxy in front of the PBX, it's the right solution. So I think a session border controller can help. Yes.
Yeah, I'd echo that too. And it always amazes me when we have people like David Duffett there running around with his Raspberry Pi in his pocket, running all kinds of weird and wonderful things. What's that, $35, $40 platform? Powered with a battery, and you compare where we were 15 years ago. It's incredible. Any last questions? Because if not, I would like to say thank you to Flavia.
Thank you. Thank you so much. I like